with Bruce?
No.
Go away.
Now, number 4 there is the question about the bumper car. I'm sure... Huh?
No, it's still wire.
Still wire.
Oh, I thought it was about the bumper cars. That's why I was so excited. The steel wires. Okay. That's not as exciting, but let's have a look. Huh? You want the bumper car one as well? Okay. That makes me happy. Monica, can you read the story about the steel wires? What's happening in that one?
Steel wires support a lift.
Yeah.
The lift has a mass of 1,500 kg.
Okay. Now, is it one steel wire or
Just the steel wire.
a steel wire? Okay. Supports a lift.
The lift has a mass of 1,500 kg.
Mhm.
The wires
Okay.
are 2 centimeters thick. Oh, there are 4 wires in total. By how much per meter should the wires of 10 wires with 260 kg people enter the lift?
Okay. So what's interesting here, and I did this on purpose to confuse you, the mass of the lift is not important because at the beginning of the story, the mass is already hanging from the lift. Its mass is not important. It is only the extra mass that you put in that causes the extra extension that matters. So in fact, on purpose, I included this to try and trick you into including it, but it's not necessary. I'm looking for the extension. So Young's modulus is stress over strain. Yeah. So the extension is F over A over E over L. Okay, now the L is 1. So that's F over A over E. Okay, now the force is the weight, which is mg, and the area is pi r squared.
Why don't you put 4? There's 4 wires.
Yeah, I was just about to add in a 4. So in total the area is 4 times bigger. But then the weight for each one would only be 1/4. So if we think about this carefully, there's 4 wires and the weight is split on the 4 wires. So actually really here it should be 1/4. If I just look at one wire, I'm just looking at one of the 4 wires. So I split the mass in 4, shared equally. Okay. So let's see. The answer will be 120 over 4, which is 30, times 9.81 over pi 0.01 squared over what's Young's modulus for steel? I can't hear you, I'm eating chocolate. 100? 200? Okay. So what do we get here? Do we have an answer calculated? Can you calculate, please?
Wait.
No, I'll save it. Got a calculator, KJ? Uh, 4.69
8.
6, 9 times 10 to the minus
micrometers.
The answer is 18.7.
Outrageous. That's a disgrace. My answer is what now?
18.7.
You didn't put 4 over 4. Yeah.
Ah. Did I say in the question there's 4 steel wires?
Yeah.
I will now change it. The question said 1 steel wire. Now my answer's right. It's my workbook. I can change the questions. Now it's just 1 steel wire. Now the answer's right. Bumper car time? No, the answer seems like it's 4 times. The answer at the back of my worksheet seems like it's 4 times bigger than this. So it seems like, yeah, I missed the 1 over 4. What?
Because it was 120 over 4 by, I don't think it's 4 months.
No, it does, because there's 2 ways to think about it. Either you look at each wire and the mass split equally on each wire, or you look at the total mass on all the 4 wires. So you would have, whoops, instead of having a quarter here, you would have a 4 here.
It's the same.
It's the same answer.
No, I mean 1 over 4 mg is same as 1.
Yeah, no, I know this. Okay. You don't study maths at university for 5 years without picking up a few things, so I know this.
Okay.
What I'm saying is, it sounds like in the video I completely forgot that there were 4 wires. Yeah, no 4 present in my fraction, it would sound like. So I'll just change the question so there's only 1 steel wire. Problem solved. Okay, bumper car next. I was so happy with that question when I thought of it. Really like it. True. Okay, we'll have Chu read the question to us. Go for it, Chu. Read the last question, number 4 there.
Golden bumper car. Bumper car.
You're correct, yeah.
Golden bumper car traveling at 10 km, 10 kilometers per hour with mass 300 kg crashed into a barrier. The front bumper is made.
Okay, I'll need you to pause there. I'm still drawing my car. Right, 10 kilometers per hour, and it's 300 kg. Okay, continue.
The front bumper is made of rubber and is in the shape of 75 cm by 5 cm by 5 cm cube.
Great.
The collision caused the bumper to compress and find the following
Okay. Okay, let me just put a person in the car. And we can start. Okay. So what's the first thing I asked? Well, do you understand what's happening? This is a bumper car. What do you mean? What are you talking? What's? No. That's the bumper. That's the bumper of the car. The bumper of the car. 75 centimeters is what, this wide? But that's the bumper. That's the front of the car. The bumper. You were picturing them inside this, weren't you?
No.
Yes, you were. No, I can't change it. No, I can't change it. Can't change it.
No, I was picturing the front part of the car, but now I realize that's down part.
I don't know what you're saying, but do you understand it now? You can understand my picture, everybody?
Yeah.
Yes. Okay. You know at the fun fair, the fairground, The bumper cars, they bump into each other.
Yeah.
Yeah, okay. So, what's part A? Chu?
The stiffness constant.
The K. Yeah. So, Young's modulus, which we know, is force over area, extension over length. Yeah. But Hooke said F equals Kx, or K delta X. So, E equals K delta X over A over delta X over L. This is nice because you get E equals K over A 1 over L. Yeah. And what was I looking for? The K. So I get K is EA sports over L.
EROA. The K. No.
Is it? Is this right?
KL over A
E
equal
equal
E.
KR over A.
Yeah.
K equal E.
What?
ER over A.
KL over A equal E.
Hold on. You're saying K is what?
Yes,
It's correct.
It's right.
it's right. You're right.
Thank you. Thank you. Okay, so do we know the E, the Young's modulus for rubber?
Rubber.
We do.
Yes.
Yeah, we can. We can look it up. So let's have a look here. This means K. What is it, Sean? Do you have it there?
0.2. Okay. 0.1.
0.1.
10 to 9.
10.
Power 9.
Like this?
Yes.
What's this called, Sean? This one here?
10 to power
No.
9.
Yeah, but what's this called?
Multiplier. 5.
Okay, fine.
Easy.
Fine. Right. That's the E. The L. Now, what's the L here? What's the L here?
55. 75.
5 centimeter.
What?
Because it's hitting the wall
Oh.
here. This is the L. And what's the A? The A is this.
Yes.
5 by
Five.
75. So that's 5 and that's
Yes.
75. Now that's nice because they cancel. And you have 0.075 times 10 to the 9. 1, 2, 3. 10 to the 6 newtons per meter. That's the K for this rubber bumper. 75 times 10 to the 6 newtons per meter. So because the K is so big, it means it's quite stiff, which is what you expect from a rubber bumper. It shouldn't really be too squishy. Next part. Okay, what's next, Chu?
The amplitude A.
The amplitude A. Man, I made this question so hard, I need a second to remember how to do this. It's going to be energy, that was it. So, what's happening here in the picture, the car has kinetic energy,
Yes.
but when it hits the wall, it stops and the energy goes into the bumper by compressing the bumper. So basically you can say a half mv squared, yeah. A half k a squared. This is the formula for the energy when you compress the spring. What we're looking for the A. Okay, so we get mv squared over k. That's the A. So that's v square root m over k. Now it's 10 kilometers per hour. What's that in meters per second? Like 16 or something? 10,000 divided 3.3 or something? Can you convert it? What is it in meters per second, please? 10,000 divided by 3,600. What is it? 2.78. Square root. What's the mass of the car? 300, is it? Is it 300? Does that include a person or not?
We'll just make 300.
Okay. And the K is 75 times 10 to the 6. So, well, that can be simplified in my head, because 3 goes into that 25 times, so that's 100 over 25 times 10 to the 6. 25 goes into 104 times,
Four.
square root of 4 is 2, so this is 2.88 times 2. This is 10 to the 2, 10 to the 6, 10 to the minus 4, root of 10 to the minus 2. So what's that? 2.55, 6, 7, 8, 38, 576 times 10 to the minus 2. Make this a bigger, make that smaller. Is it 57.6 millimeters?
Nope.
No,
Right.
China 75 to
5.56.
25.
I changed 75 into 3 times 25.
Okay.
What is the correct answer?
5.56.
Millimeters?
Yeah.
Alright. Well,
Maybe
that's-
because of that, 2.88 is 2.78.
Oh. I did the hard part right and the easy part wrong. Because of this. Disgraceful. Alright, what should it be?
5.56.
5.56 millimeters. Okay. Yep. No? Continue? Chew! Next part.
The time the buffer then compressed.
Great. Now, normally the formula for the time is this. 2 pi root m over k. However, we only want half of this. Why? Why do we only want half the time? It's half an oscillation, just to compress. Yeah, yes, we only want half of this. Okay. Pi root 300 over, what was my k? Something like 75, wasn't it?
75
10 to the 6.
by
Yeah, okay. 25 times 3 goes into that 100 times. 10 to the minus 4, 1 over 5. What's it? Pi over 5. 10 to the minus 2. Can someone just hit it in on the calculator to make my life easier, please? Nah, Sean, let's just be lazy. Please go and type it in.
pi by 2 by
Wow.
Give up, Sean, give up.
No, you can't give up.
6.28.
Milliseconds.
6.28 milliseconds. I know, Sean, I know. Okay, D is probably find the force.
Yeah.
So the force on the bumper will be the change in momentum over the time. The time is 6.28 times 10 to the minus 3, and the momentum will be mv minus mu, but of course the v is 0. So it will be minus 300 times, what did we say the speed was? 2 point something, wasn't it?
2.78.
Okay. So what do we get here?
oh.
Zero. Should be a big number. Did you have minus 3 in the denominator?
Yes.
What's the answer, Sean?
Got 13280 2 point 5, 4,
Okay.
7, 8. Yes.
Minus 133 kilonewtons. Now you might think, I know another way to get this. If you're looking for F, you can use the formula. What's another formula for F? You might be thinking. Not G in this one, Sean.
No, sorry.
MA.
MA.
And A is V minus U over T. And we know the V is no square. Yeah. We know the V is 0, so that's minus mu over T. And then you realise, oh, but that's the formula you just had earlier. I mean, because this was the M, this was the U, and this is the T. So, same answer here. What? That's yeah, I know, but I made. Yeah, no, it is. I made it easier by making it a rectangle rather than a circular thing. Okay. Good question. If I do say so myself. Alright, what's next now?
The fourth.
Oh, there's another part. I thought we were finished. E, is it? Huh?
No,
It's finished. Oh, we're finished, don't worry. We did it, yeah. Yeah, it's all finished. Don't worry. I thought there was more. Okay. What's next now? What else do you need to see? Answers? For what? They're all on YouTube. But I can print them out for you. No problem. I can even text them to you, but I don't know if you'd like me texting them to you.
Yes.
Yeah, you want me to text them?
Yeah.
Okay.
I like printing better.
Yeah.
I'm not going to do both, okay?
Because
I'm too busy to do both. I can't print and text. That's ridiculous.
it's hard to see through my screen.
I know it's not. I will print and text. Don't make that face at me. You thought I was going to say, I said, I'm going to print, and you're going off, not happy with this.
Could you just print out only the answer, like answers?
No. Why?
Part one, something.
What's wrong if I print the questions again?
Because it's too much. And the wait.
Cry me a river.
Wait.
Wait. I don't believe in that stuff.
See?
I'm more of a
Same
environment.
I don't believe in that.
Oh, wow.
Yes.
What's next, so? What do we want to see next?
Resistivity. Yeah.
The copper. Both parts? Yep.
Yeah.
Yep. Right. Number 4. Okay, we'll get our buddy Sean to read. Go for it, Sean. We believe in you. Number 4.
Telephone company is laying down copper wire. Yeah?
Copper wire, yep.
Copper wire. The copper wire is 4 millimeters in diameter and is 2 kilometers long. The current runs through the wire.
Yep. So,
Question. What resistance does the copper wire offer?
perfect. Resistance is resistivity, L over A, which is L 2000 over pi, or
2.
yeah, 2 to the 10 minus 3. Yeah, pi or squared. Okay. What is the resistivity of copper? Quite low, isn't it?
1.7 to 10
-8. 10 to the -8. Okay, so when you bash this into your calculator, you get like 2.72, is it? 2.74 ohms. B. I take this copper wire and I wrap it with 7 other copper wires. So I have 7 of these now. And they're all together. So what's the resistance now? Well, all that's really changed is what? The area is now 7 times bigger. 7 times bigger.
7 times.
80004. We have picture.
No, 002.
2.
Because this, yeah.
Diameter.
Diameter. Correct, yeah.
We need it.
We need what?
Half diameter.
Yeah, what's half diameter called?
Half.
Yeah. Radius. Radius. Yeah.
Radius.
So why are people saying tree here for
We
this?
have picture.
So?
And it is tree.
Like if you make that.
What are you talking about? I can see 7.
No,
No, stop. We're not looking at the radius anymore. We're looking at the area. There's
Yeah.
7 more circles. So the area is 7 times bigger. I don't care about the radius.
Okay. This is too much work.
So the answer is 7 times smaller.
Oh yeah. Area.
No.
Yeah, not half diameter radius.
Radius.
That's funny, I didn't expect that to be what would confuse you, but there you go. Okay. Is that okay?
Yeah.
Yep. What's next now?
Oh, 5A.
5A, show me 5A. Is that the picture? Oh yeah, that's a nice one.
Did you give us the worksheet?
For what?
Should I select?
No, if you were there, which you were,
Yeah.
you
Oh,
remember
now I
that you had to
remember.
take the picture and you were going, rainbow, blah, blah, blah. I don't like that there's a rainbow
So the central circuit is our last one, right?
that I printed, but I'll print the other 2 from today. I just finished typing them up,
Oh.
so I didn't get a chance to type them. Actually, if I have time, I'll print them in between these classes. I'll bring them down. And the answers from the previous worksheets.
Oh. It was working.
It was you complaining about the rainbow colour, or was it one of them? Yeah.
No, it doesn't fit the iPhone. It doesn't do it anything.
No, it's not just this one.
Okay.
Okay, we got that. We look at the simple circuits now. Okay, right. In total, KJ, what's the voltage down the bottom? 12, okay. And how big is the first resistor here?
3.
2 ohms? 3 ohms?
4 ohms.
4 ohms, okie dokie. And basically I want all the voltages and currents, basically. Right, first thing, let's add the 3 and the 4 together. That's 4 12ths and 3 12ths is 7 12ths, isn't it? Yeah, so the total resistance here will be 2 plus 12 over 7. Which is 14, 26 over 7
Yes.
ohms. Okay. Is that okay so far? Yeah. I have enough information to work out the current. the current is the V over the R, which is 84 over 26 amps. Okay, let's start using decimals, please. What's this as a decimal? 3.23 amps. So, in my original picture, that means here, there's 3.23 amps. And that means here, through this one, it's 3.23. One answer down, 5 more to go. We need to get the other currents and the other voltages. Okay. So, if I go back to this picture, I now know the current and I know the resistance. So, using my triangle again, I can get the voltage as IR. So that would be 6.46 volts. Good news. Whatever the voltage is, it must be the same as these two. And the total must be the same, I mean. And, what are you going to say, Sean? Total is 12. So 12 minus 6 is, what's that, 5.54?
Yeah.
And that must be the same down here. Wonderful. So there's only two things left to find. What are my last two things to find? The current through the tree and the ore. So again, by using this triangle, I can say current is V over R. So for the top one, the current here will be 5.54 over 3. And for the bottom one, it will be 5.54 over 4. And these two should add to be the same as this. Yeah. So what is this one, please? And what is this one, please? 1.85 amps. And the other one?
1.39.
Now, I have found the three voltages and the three currents. Yeah, this is a good question for, the exam, because it kind of really makes sure. What I like about this question is it makes sure you completely understand how voltage and current behaves in series and parallel. That's really what this is testing you for. That you understand how voltage and current behaves in series and parallel. So it's a good question like that. Okay, what's next now? Have we got time? Not too crazy of a question.
Done.
Yeah?
You.
Really? You don't have any more you want to ask? Yeah?
You don't have to do any T, a period
The spring?
Yeah.
You want the formula? Yeah. The formula is the period. No, this is when something is oscillating, a spring. The T equals 2 pi root m over k. And just to be clear, what is very interesting about this is it doesn't matter if it's lying horizontally or if it's lying vertically. It's the same time, because you notice this formula does not have a G in it. This actually means if you did this on the moon, you get the same answer. So that's quite interesting. And also, you don't really care about the mass of the spring. It's the mass that you attach to the end that causes the vibration is what is of importance.
Is there a proof?
There is a proof. I can do the proof for you, but it'll take it'll take about 10 to 15 minutes. It's not a short proof. Oh yeah, it's quite. It's quite a long proof, but it's not impossible to prove. If you're desperate to see it today, and not willing to wait, if you go to my YouTube channel and if you type in the name of the lesson and look at the video from last year, or maybe the year before last, in one of those lessons I proved it, but I don't really prove it anymore for two reasons. One, the proof is not on the exam, and two, the proof is not, you don't need the proof in your coursework, your lab work. So it's a bit unnecessary to prove it. But if you're interested, you can try and find it. But if you're willing to wait, I can do it in the next tutorial. Okay, to maths.